our advanced multi-criteria detector, we've combined an electrochemical carbon monoxide sensor with a photoelectric smoke chamber, solid-state thermistors for thermal detection, and to that we've also added a daylight-filtered infrared sensor. The benefits are really twofold. First, it allows us to provide the most accurate fire detection possible, while at the same time providing you superior nuisance rejection for those problem sites. Different fires have different characteristics, and each fire is a little bit different. By combining these four elements, we can successfully filter out nuisance concerns and provide you accurate fire detection. And we've got four detection elements working simultaneously, so photo, thermal, carbon monoxide, and infrared being detected simultaneously. And then this white band up here represents the composite signal. So as you see time moving, you'll see the graphs moving along. And the composite signal basically represents what the detector would be feeding back to the panel. So it's internally processing these four elements and then taking that composite and sharing that information with the panel. So first thing I'll demonstrate is a typical nuisance condition, a theater smoke, disco fog, something you might see in a theater type application. As I flood this chamber with the theater smoke, you'll see the photo detector portion of the device respond, and I'll give it a fair amount of smoke. We should be able to, yeah, we can spike it right up to, right now we're at 7% per foot of smoke, so it recognizes that. Now we've moved up to 9% per foot of smoke. The interesting thing though is you notice the composite, no movement there. Again, it sees the element, but it recognizes that I'm missing other components of a real fire. I have hit a pre-alarm level because I flooded it so heavily, but not sufficient to put the device in alarm. I'll go ahead and just evacuate the chamber, bring my pre-alarm level back down. And then what I'll do is I'll go ahead and we just put in basically an infrared heat lamp like you'd find in your bathroom in here. You can see it'll recognize the infrared, so once it hits its next time band here, you'll see the infrared spike up. It's basically almost like an on or off type indication. If I hold it down long enough, I can actually usually generate some heat as well because we've got such a confined chamber here. But again, you can see it recognizes it. Nothing's happening on the composite because we don't have the right elements here to say this is a fire condition. So I'll go ahead and let that come back down. Then what we're going to do, we've taken a cotton wick, wrapped it with a fine bell wire, and we're passing a current through it. Causes the wick to smolder, representing a true fire situation. So given about 15-20 seconds, and that should be pretty good right there. You'll see the photo respond first. It'll start to come up. Then not long after, carbon monoxide starts to come into play. Once it sees the combination of both of those over a period of time, then it knows, yep, this is indicative of a real fire. Yeah, now we're starting to see some carbon monoxide. So, and it's responding as it should. There we go. And we trigger our strobes. The device, the unit, as you'll see, the LEDs are on. The device is in alarm right now.